We are recording now.
Can you make me the presenter?
Yeah.
Can you see my screen?
Yes, we can.
Oh, Lord. Thank you so much. Once again, sorry for missing out the last class. Like I said, I was bereaved in a way. And fine now. So today we'll be looking at mobile, Linux, and Mac OS operating system. We did talk about the operating system in the previous class. But here we'll be looking at the mobile Linux and Mac OS operating system. And we're going to look at some of the objectives here, which is to explain the purpose and the characteristics of mobile operating system, which is need for us to compare the Android and the iOS operating system. We'll describe the features of the Android touch interface, the features of the iOS touch interface, describe the features of Windows touch interface. So we're looking at Windows, Android, and the iOS. Okay, so we'll also look at operating system features that are common among mobile devices and methods for securing mobile devices, under which we explain methods for securing mobile devices, that explain how to configure various types of passcode locks, describe cloud-enabled services for mobile devices, describe software security for mobile devices. And then we'll look at Linux and Mac operating system. Under that, we'll look at the purpose and characteristics of Mac and Linux operating system. We'll describe tools and features of the Linux Mac operating system. Describe Linux and OS X best practices. Define basic command line interface commands, and then basic troubleshooting process for other operating systems. We'll explain how to troubleshoot other operating systems by looking at the 6 steps of troubleshooting. These we have discussed in the previous classes. And then it's also peculiar with 2012. Describe common problems and solutions for other operating systems. So quickly, let's look at the mobile operating system. When you talk about the Android versus iOS of the operating system, we have what we call the open source versus closed source. And when you say open source, you're looking at operating systems where the code, the program source code, are made available to the users, and then they must be able to see the code, so it's open for developers to also add to it. But when it's closed, it requires some level of access, in other words, customized for certain purposes. So the open source is free, it's open, it gives developers to add additional functionalities. But when it comes to the closed source, you don't have such privileges. So Android is developed by Google and iOS is developed by Apple. So for example, the Android is open source, and then the iOS developed by Apple is closed source. So applications and content sources. Apps are written and compiled for specific mobile operating systems such as Apple iOS, Android, or Windows. The mobile devices come with a number of different apps installed to provide basic functionalities, which we're aware that apart from the operating systems, you have applications that run on these mobile devices. So there are apps to make mobile phone calls, send, receive emails, listen to music, take pictures, and play video, or video games. So each of these functionalities actually are tied to certain applications. So you have application for email, you have application for music, you have application for pictures, and all embedded in the content source. So instead of being installed from an optical disk, apps are downloaded from a content source. In the case of Android, you're looking at the Play Store. So application and content sources. So apps for Apple iOS mobile devices are available for free or purchased from the App Store. Okay. And then Apple uses a walled garden model for their apps, meaning the apps must be submitted to and approved by Apple before they are released to users. So you can see the procedure for that of Apple. And this helps prevent the spread of malware and malicious code, unlike that of Android. So Android apps are available from both Google Play and third-party sites such as Amazon App Store. Android apps run in a sandbox and have only the privileges enabled by the user. So you can see the differences between the Android and that of the iOS. So the third party or custom programs are installed directly using an Android application package, which is called the APK file. For you to be able to install additional applications on Android, you need the APK. So this gives users the ability to directly install apps without going through the storefront interface and is known as side loading. That's for you to be able to upload new applications on Android. So here is some home screen items. Some of us that use Android and a lot of us that use Mac iOS were also attested to this. So this is like a typical environment of what a typical environment of what a typical Android phone looks like or mobile device looks like. So Android main home screen. One screen is designated as the home screen. Additional screens are accessed by sliding home screen to the left or right. So you slide through, you're able to access the other content. The Android OS uses a system bar to navigate apps and screens, and the system bar contains the following buttons: the back, the home, the recent apps, and menu. And so this we can also see from the picture on our right hand side. So here is the home screen. So we have the notification and system icons on our Android phone. We also have the battery status, we have the clock, we have the Wi-Fi and provider networks, all that are available, which you can see on the notification system of the icon. So when you actually check your Android phone, you see all those notifications, oftentimes at the top right-hand corner. So open, and then some of them you can see at the bottom. So open the notification area of the Android device, sweep down from the top of the screen. So once you sweep down, you'll be able to see all of that, and you can do the following when notifications are open. You can respond to the notification by touching it. You can dismiss one. You can dismiss all. You can toggle off to use settings. You can adjust the brightness of your screen from there. You can also open settings menu with quick setting icon. So we have a lab working with Android. In this lab, you place apps and widgets on the home screen and move them between different screens. You also create folders. Finally, you will install and uninstall apps from the Android phone. So this was there to actually demonstrate to show our students how to do this on their Android devices. So here's the home screen items. For the iOS interface, the iOS interface works in much the same way as the Android interface, but there are so many, there are some very important differences. No navigation icons like we have, so we can see this as one of the examples. No widgets, only apps and other content can be installed on iOS. no app shortcut. Each app on home screen is the actual app, not a shortcut. In the case of the Android, then the home button, unlike Android, iOS devices do not use navigation icons to perform functions. So that we can also agree. And then some functions performed by the home button include the wake device, return to the home screen, start Siri or voice control, which completely makes the iOS phone mobile devices different from that of the Android phone. So the home screen items, you can also see the iOS notification center, commonly used centers. So these are actually a kind of the differences. We're going through differences between the Android and Mac iOS. And so we can look at the two labs side by side and see the difference. So you place an app on the home screen and move them between different home screens. You also create folders. Finally, you will install an app on the iOS device and then uninstall it. So that when you do this on the iOS and you do the same on the Android phone, you see the difference between both. And then the screen orientation. Let's look at both of them. Screen orientation. So most mobile devices can be used in either portrait or landscape mode, which you can also turn around. A sensor inside the device known as the accelerometer detects how it is being held and will.
Hello, we lost the sound.
Devices also have the
Dr. Daniel? Hello?
Hello, Marilyn. Hello?
Sorry, I was on mute. Can you hear me?
Yes, I can.
Mm-hmm. Hello,
Anyways,
Simon. How are you feeling?
pardon?
Yeah?
It's like I've been made the host.
Yeah, because the instructor dropped. I guess he's having some kind of connection issue. So as soon as
Yes,
he's back, he will take the host.
okay, okay.
So Simon, are you okay? I cannot hear you.
Hello.
Hello, we can hear you now.
Oh, I lost you guys. Oh. Can you make me presenter? Okay. Seems I'm the host now.
Yes.
Can we see this? Can we see the screen?
Yes, now we can see.
Okay. Okay. So we're talking about the screen calibration for mobile device features. So when bright sunlight makes the screen difficult, you can actually increase the brightness, directly. And inversely, the low brightness help when you're reading a book. So some mobile devices can be configured to auto adjust brightness depending on the amount of surrounding light. The device must have a light sensor to actually do this. Okay, and then Android. Hello, can you hear me?
Yes, we can hear.
Okay, thank you.
Yes, we can hear you.
Okay, thank you. So Android brightness menu. So when using an Android device to configure screen brightness, you go to settings, you go to display brightness, and then slide the brightness to the desired level you want. Sometimes you can make it full and half. But I think it's obvious that at night you can read it when you reduce the brightness. So when using an iOS device, that's looking at the iOS display and brightness menu, which is quite different from that of the Android, to configure screen brightness. You sweep up from the very bottom of the screen, slide the brightness bar up or down to vary the brightness. I think this is more interesting when you actually have the two devices in front of you to compare. So here we'll be looking at the GPS, which is the global position system. It's a navigation system that actually that determines the time and geographical location of the device by using messages from satellites in space and receive on Earth. I think the GPS has actually added a lot in the mobile technology. Prior to now, remember far back then, we usually use a full GPS device, to actually track location for we call an option file for GSAT installation. I mean, that was quite difficult then to do all of that. But today we have it on our mobile devices, so people can actually get their location in real time. I mean, these are actually additional features we're enjoying today. So GPS services allow app vendors and websites to know the location of the device and offer location-specific services, which is called geo-tracking. So the indoor positioning system, which is the IPS, can determine device location by triangulating its proximity to other radio signals, such as Wi-Fi access points. In the case of the Android location services, to enable a GPS on Android device, you go to Settings, Location, tap on the toggle, turn Location Services on, and once you do that, the GPS comes on. And the iOS location services, to enable GPS on iOS device, you also go to Settings, you get Privacy, Location Services, and then turn Location Service on. So in this lab, you will learn about mobile device features. So I think it's nice we get the lab done. And then the Wi-Fi calling. The Wi-Fi calling, instead of using the cellular carrier network, modern smartphones can use the internet to transport voice calls by taking advantage of local Wi-Fi hotspots. Okay, and if there is no Wi-Fi hotspot within reach, the phone will use the cellular carrier network to transport the voice call. So you can see it works in both ways. So the Wi-Fi calling is very useful in areas with poor cellular convergence because it uses a local Wi-Fi hotspot to fill the gap. So the Wi-Fi hotspot must be able to guarantee a throughput of at least 1 megabit per second to the internet for a good quality call. As for you to actually do calls on Wi-Fi, you need this amount of bandwidth. I mean, that will help to reduce, of course, the losses will not be obvious considering the speed. But if you operate within less than this speed, you're going to have some issues. So the Wi-Fi calling on Android. To enable Wi-Fi calling on Android, you go to Settings, you go to More, and then under Wireless and Networks, you tap on the toggle to turn it on. And then to enable Wi-Fi calling on iOS, you go to Enable Wi-Fi calling on iOS, you go to Settings, Phone, and turn on Wi-Fi calling. So with that, you're actually using the Wi-Fi to make your calls. And so here we're looking at the near field communication and payment. So mobile payment refers to any payment made through a mobile phone. We have what we call the premium SMS-based transactional payment. This is where the consumer sends an SMS message to a carrier special phone number containing the payment request, and the seller is informed the payment has been received and is clear to receive the goods. Okay, and then this is actually used in the case of business transactions. Then the direct mobile billing, in this case, you're using the mobile billing option during checkout. The user identifies their self through two-factor authentication and allows the charge to be added to their mobile service bill. These are actually applications that run on the mobile device. And then the mobile web payment, this is the case where the consumer uses the web or the detected apps to complete the transaction. And then we have the countless NFC. In this method is used mostly in physical store transactions where a consumer pays for goods or services by waving the phone near the payment system. So you can actually take it close to the payment system. And I mean that some of them use barcodes, so and then you can be able to deduct payment and the amount from that account. So we have what we call the virtual private network. The VPN is a virtual network that uses a public network and usually the internet to connect remote sites or users together. So you can actually have a VPN on your mobile device. You can have your VPN on your normal internet network. But the VPN itself is a private network that exists on the internet or the cloud connection that provides some kind of secure link between two private organizations. Many companies create their own, of course, VPN to accommodate the needs of remote employees in distant offices. So when you actually create your own, this you can do with the help of the Cisco router as well. So when you be doing the CCNA, you also do some configurations on VPN. So that with this, you can have two different organizations actually want to do business and create a private connection between themselves and then on the internet. So you could have the private IP addresses at two ends with the cloud, which is of course the public IP address. So that is possible. So because VPN protocols also allow for data encryption, the communication between client and staff is secure. So it's actually encrypted between both end devices. So configuring a VPN connection on Android, what do? You go to settings, you go to more, you go under wireless network, you go to VPN and tap on the plus sign to add a VPN connection. So configuring a VPN connection on Android, what do? You go to settings, which is general VPN, then you can create that on the mobile device. Then in the case of a public network, you have to do that on your WAN connection, that's on your LAN, on your router between the two locations. So for the virtual assistant, a digital assistant, sometimes called a virtual assistant, is a program that can understand natural conversational language and perform tasks for the end users. So these digital assistants rely on artificial intelligence, machine learning, and voice recognition technology to understand conversational style voice commands. We have this in our phone, and most of us actually are using this, quite useful. So by pairing simple voice requests with other inputs, such as the GPS location, these assistants can perform several tasks, including playing a specific song. You can also perform a web search and take a note or sending an email. Sometimes it works with even voice. While you talk, then you can see it writing out and all of that. And then for Google Now, to access Google Now on Android device, you simply say, "Okay, Google," and Google Now will activate and start listening to requests. So this is actually some kind of virtual assistant. Instead of doing this thing manually yourself, it's a way of making these things smarter, especially for people who are maybe impaired in one or two ways. This actually goes a long way to help them. And then Siri is to access Siri on Android, on iOS device. You press and hold home button, and Siri will activate and start listening to requests. Alternatively, Siri can be configured to start listening when it hears "Hey Siri," and then it comes on and responds. I mean, you have the artificial intelligence setup. So what we're saying is that this is more of machine language and voice recognition. So let's look at the method for securing mobile devices. In the lab, you set up a passcode lock. You change the passcode lock and you fail the passcode application. So you also configure the device to use fingerprint if it has a biometric capability. And finally, you remove the passcode and the biometric lock. This is just to check out the authentication security level on the device. Of course, when it comes to this security aspect, it varies from phone to phone, and depending on the model of phone you're using. So restriction on failed login and payment. When a passcode has been configured, unlocking a mobile device requires entering the correct PIN, in this case, password, pattern, or another passcode type. So you have different ways of actually a kind of locking of the phone. In theory, passcode such as a PIN could be get given enough time and perseverance, So to prevent someone from trying to guess a passcode, mobile devices can be set to perform defined actions. After a certain number of incorrect attempts have been made, can actually lock, for some time and then release it. But iOS release that if the passcode fails 10 times, the screen goes blank and all data on the device is deleted. That's the case of the iOS. To restore the iOS device and data, use either the restore and backup option in iTunes or iCloud. So you can see the difference between the two here. For that of iOS, if that attempt fails 10 times, this is the consequences. But of course, it can still be restored when you have done, you've actually created a restore point. Then the iOS graphical user interface. On iOS, to increase security, the passcode is used as part of the encryption key for the entire system. So we can see here remote backup. So a remote backup is when the device copies its data to cloud storage using a backup app. And this you can also see in the case of Android, download from the Android store. And most mobile operating systems come with a user account linked to the vendor's cloud services, such as iCloud for the iOS, and in the case of Google Synchro for Android, and OneDrive for Microsoft. So to see each of these have their own app that helps to carry out the remote backup. Okay. So the locator application, if a mobile device is misplaced or stolen, it's possible to find it using a locator app. A locator app should be installed and configured on each mobile device before it is lost. Because if you do that, then it will actually tell us where the location of the missing device is. Both Android and iOS have apps for remotely locating a device. Okay, so Android Device Manager allows the user to locate ringed or lock a lost Android device or to erase data from the device. And then the iOS users can use the Find My iPhone app to actually locate this missing device. So after the device is located, you might be able to perform additional functions such as sending a message or playing a sound. So these must be installed in the device for you to be able to track this device. Okay. Still the same. So let's look at the antivirus. Smartphone and other mobile devices are vulnerable to malicious software. So depending on the permissions granted to antivirus apps, when they are installed on Android device, the app might not be able to scan files automatically or run scheduled scans. So iOS does not allow automatic or scheduled scans. So this is a safety feature to prevent malicious programs from using unauthorized resources or contaminating other apps or the OS. So the mobile device apps run in a sandbox. Okay, so a sandbox is the location of the OS that keeps code isolated from other resources and other code. So it is difficult for malicious programs to infect a mobile device because apps are run inside the sandbox. So to prevent malicious programs from infecting additional device, a firewall can be installed. And if you do that, that helps you to actually take off this malicious program. But then you can also install your antivirus also your mobile device through your app store. And then routing and jailbreaking. This is also a software security trend. the mobile operating system are usually protected by a number of software restrictions. An unmodified copy of iOS, for example, only execute authorized code and allow very limited user to access to its file system. So routing and jailbreaking are two methods for removing restrictions and protection added to mobile operating systems. So you can use routing as two predominant methods for removing any restrictions and protection. What is routing? Routing is used on Android device to gain privilege or root level access for modifying code or installing software that is not intended for the device. While the jailbreaking is typically used on iOS device to remove the manufacturer restrictions, allowing them to run arbitrary user code, grant user full access to the file system and full access to panel modules. So with this, you can be able to now begin. That actually makes the system more vulnerable. So by routing or jailbreaking in mobile device, the GUI can be heavily customized. Modifications can be made to the OS to improve the speed and the responsiveness of the device, and ARMs can be installed from secondary or unsupported sources. But once these are enabled, it will be difficult for you to be able to increase the speed. So what we're saying is that you can turn this off to be able to achieve this objective. In as much as it also makes the device vulnerable, but that would be for the period. And then patching and updating operating system. Like the OS, of course, of our desktop, of course, once in a while, we need these patches from maybe from Microsoft or from some of these, just to keep the system refreshed and more, the constant updates, and you have these patches for maybe some programs that are failing. It keeps the operating system more of alive, in other words, more stronger. And then instead of having defective codes that will fail over time, if you have these patches being updated on a periodic basis, it helps the operating system to actually last longer. So patches can fix security problems or issues with hardware and software. So Android updates and patches use an automated process for delivery. So when a carrier or a manufacturer has an update for a device, a notification on the device indicates that an update is ready. Sometimes it pops up on our phone, so they would probably to update the device. Okay, so iOS updates also use an automated process for delivery, similar to Android. A notice to download opened if updates are actually available. So there are two types of updates for mobile device radio framework. The first one here is the preferred roaming, which is it's configuration information that a cellular phone needs to communicate on the network other than its own so that a call can be made outside of the carrier network. So here you're looking at types of update for mobile device radio framework. And then secondly, the primary rate IBM pre-configures the data rate between devices and the cell tower. This ensures that the device is able to communicate with the tower at the correct rate. So in this case, you're actually looking at the mobile device with the radio tower communication. And these are actually two types of updates for mobile devices, radio firmware. So let's look at Linux and the Mac OS. What is Unix? Unix is a proprietary operating system written in C programming language. Okay, and the Mac OS and the iOS are based upon the Berkeley standard distribution version of Unix. Okay, so when it comes to Linux operating systems are used in embedded systems like your wearable devices, smartwatches, cell phones, your netbook, PC servers, and supercomputers, they all have Linux embedded in them because they are rugged and actually can withstand a lot of maybe surge and all that stuff, unlike Windows that can actually fail when you subject them to what we call maybe power regression test and all of that. So there are many different distributions or distros for Linux, including the SSE, the Red Hat, the CentOS, the Fedora, Debian, Ubuntu. These are all different types of Linux. Android and many OS distributions rely upon the Linux kernel for them to function. So the Mac OS, so the operating system for Macintosh computers is developed from the Unix kernel. Okay, it is, however, a closed source operating system that we said before. So the Mac OS supports remote network installation called the network. So this is overview of Linux. GUI, that's the graphical user interface of Linux. So different Linux distributions ship with different software packages. It all depends on the Linux type. Okay, so the graphical interface in Linux is comprised of a number of subsystems that can also be removed or replaced by the user. So Ubuntu Linux uses Unity as its default GUI. The Linux GUI has the ability to have multiple desktops or workspaces. And then the Canonical has a website that simulates Unity UI and then through the Unity main features. So to experience Unity via the Canonical website, you can actually check on this, that's on the Ubuntu site, to be able to see this functionality. But then this is a typical representation of the Linux GUI. You also have the command line also for you to be able to interact with the back end. Okay. So this is the overview of Mac OS GUI. Among the major differences between older version of OS X and Mac OS is the addition of the Aqua GUI. So with Mac OS, mission control is a quick way to see everything that is currently open on your Mac device, and which, of course, mission control allows you to organize your apps on multiple desktops. It also helps to navigate file system, which Mac OS includes the Finder. The Finder is very similar to the Windows File Explorer. So this, in the case of the Mac OS, you can see it actually use Finder, and that Finder is like when you're using the Explorer in the case of Windows. So the functionality is almost the same thing. The Mac OS allows screen sharing, okay, and screen sharing is a feature that lets other people use Mac OS to be able to view your screen and even take control of your computer, as long as you provide the access. So this is the overview of Linux in the Mac OS command line. So you can see the kernel and then the shell and then the application program. So you have the kernel as a core, and then you have the shell, and then the application runs on the shell. So to add flexibility commands that support the parameters option switches, I usually proceed by the dash character. Okay, that's the case of the Linux. So most operating systems include a graphical interface. Although a command line interface is still present, the OS often boots into your normal GUI by default and hiding the command line interface from the user base, which you can also use in the long run. One way to access the the CLI in a GUI-based operating system is through a terminal emulator. So you will actually see the terminal emulator, and once you click on a terminal emulator, you can access the command line interface on a GUI-based operating system for Linux specifically. This application provider use access the command line interface and often named as some variation of the word terminal. So when you access the terminal emulator, you'll be able to get through your command line. And then this is how you get through that. So a program called the shell interprets the commands from the keyboard and passes them to the operating system. If you look at the last picture, you could agree that you have the kernel and then the shell before the application system. So in this case, the kernel is responsible for allocating CPU time and memory to process. And the kernel also manages the file system and communicates in response to system calls. So you can see the role of the kernel in the architecture of your Linux. And then you can actually Linux backup and recovery. You can actually set this up. The process of backing up data refers to creating a copy of data for safekeeping. So when the backup process is completed, the copy is called a backup. Why backup can be achieved with a simple copy command, many tools and techniques exist to make the process automatic and transparent to the user. Linux does not have a built-in backup tool. However, there are many commercial and open source backup solutions for Linux, such as the Amanda, Bacula, FW backups, and the Dija. These are actually like third-party applications that enable you to be able to do backup. And the Mac OS backup and recovery, it includes a backup tool called the Time Machine, which you can see because of the Mac OS on your right hand side. With a Time Machine, the user chooses an external drive to be used as a backup destination. That's to actually send the files into, and then connect to the Mac by the USB or the FireWire or Thunderbolt. Most of our external drive comes with the Thunderbolt, and then be able to send your file. So Time Machine will prepare the disk to receive the backups, and when the disk is ready, it performs incremental backup periodically that is connected to it. The Time Machine stores some backups on your Mac. So if the Time Machine backup disk is not available, you may be able to restore a backup directly from your Mac device. But that actually helps you to be able to send all your files and folders to your external drive. So the overview of the disk utility. Okay. To help diagnose and solve disk-related problems, most modern operating systems include your disk utility tools. So Ubuntu Linux includes a disk utility called the disk. With the disk, users can perform the most common disk-related tasks, including partition management, mount, format disk, and query analysis and reporting technology, which is called SMART. And the Mac OS includes disk utility. That's for the sake of the Ubuntu, which is for the Linux. And then for Mac OS, in addition to supporting the main disk maintenance tasks, the disk utility also supports verified disk permission and repaired disk permission. So these are actually features of the disk utility. In other words, services that you can actually carry out on the disk in order to do extra things, that to format the disk, create partitions, do repairs, and all of that. So these are additional services that are run, and we're looking at it at the utilities, that are things you can actually do on these disks in the Mac OS and in the Ubuntu. So you could do, like we said, you could do partition management. You can mount disk partitions. You can do disk format. You can do back sector check to see the sector, the part of the disk sector that is bad. And then you could do query smart attributes, detect and report attributes about the disk health, to show you the healthiness of the disk itself. And then we can also schedule some tasks on our system. So maintenance tasks should be scheduled and performed frequently to prevent or detect problem early. So to avoid missing maintenance tasks due to human error, that system can be programmed to perform tasks automatically. In other words, for periodic check. So 2 tasks should be scheduled and performed automatically: backups and disk check. So I think these are actually essentials, because with automatic backup, you have your files and folders ready each time. And for the disk check, in case there are bad sectors, it also report that to the user. And then the operating system update for Linux and Mac OS best practices. So also known as patches, OS updates are released periodically by OS companies to address any known vulnerability in the operating system. So why companies have updated schedules, the release of unscheduled OS update is common when a major vulnerability is found in the OS code. So there's need for periodic update. There's need for updates and firmware update for your ROM, your firmware, and then antivirus and anti-malware. Antivirus and anti-malware rely on code signatures to operate. The signatures in all the signature files are files containing a sample of the code used by viruses and malware. So there's a need for this update that actually it can help to override some of these, in other words, remove some of these malicious programs. So there's a need for periodic update. And so for Linux and Mac OS security, so the username, password, data certificate, and encryption key are just a few of securing your credentials associated to the user. And this is due to the increasing number of necessary security credentials. Modern operating systems include a service to manage them. Application and other services can then request and utilize the credentials stored by security credentials manager service. So these are actually security lay down rules for your Linux and your Mac OS. Specifically, what we just talked about is for your Linux. But in the case of the security credential service on Mac OS, a keychain security credential manager for Mac OS. To access keychain on the Mac OS, you go to Applications, Utility, Keychain Access. Once you access this, you can actually now set the security level as well. But all these are ways to secure your mobile device. The is-land command output. Actually, this is for Linux. Permission defines how the user group and other access the files and the directories. So this is a command for the directories. So link, the number of links or the number of directories inside this directory. That's for the link. So you can actually see it here from the screen. This you can actually key into our normal Linux and mobile device for us to appreciate this functionality. The user display the username of the owner of the file or the directory. Then the group. Remember we said that all that even for Android and for your Mac, they still have the Linux embedded, and this is more on the kernel part of the device. So the file size display the file size in bytes, and the date and time is the data and time of the last modification. And the file name displays the file or the directory name. This actually just gives us a rundown when you issue this command on your Linux platform. So the basic Unix file and directory permission. So to organize the system and to reinforce boundaries within the system, Unix uses file permission. Okay, and then every file and directory on the Unix system carries its permission, which define the action that the owner, the group, and others can do with the file directory. So the only user who can override file permission in Unix is the root user. So the root user is more or less like the administrator. So once you have access to the root, of course, automatically you can override and do so many things. So root access is often required before performing the maintenance and administrative checks. So here we're looking at the Linux administrative command. I usually use the terminal to monitor and control users, processes, IP addresses, and other types. So this is the command for password, which allows users to change their own password at the terminal. And the PS is allows users to monitor their own processes. Kill allows users to end the processes they have started. And ifconfig, similar to Windows, which is the ipconfig command. However, this command is duplicated, and the IP address command should be used. So in Linux, if you enter the ifconfig, you're able to view, give you more information about the network settings. And then the iwconfig allows users to set and view their wireless settings. And then the chmod allows users to change the permissions of file system files that they own. I would advise that all these commands, we have a Linux system in our lab for we to demonstrate this to our students. Then the Linux administrative command requiring root access. So let's look at administrator uses the terminal to monitor and control users' processes, IP address, and other tasks. By applying some of these commands, so for the sudo, which is the superuser do, it grants the user root access without actually changing their profile. And then for the chown, allows users to switch both the owner and group of files, and then the apt-get is used to install and manage software on Debian-based Linux distribution. So you can do apt-get install, apt-get update. This helps you to actually carry out installation on new software. So if you want to install any program in Linux specifically, you use that command. And then the shutdown is used to halt and reboot the operating system. And then this duplicate is used to copy files and partitions. So we actually need that environment to be able to practice most of these commands. So like I said earlier, it would be nice for us to do that setup in our labs and allow the students to actually practice as often as possible. And the basic troubleshooting process for Windows Mobile, that's for mobile, Linux, and Mac OS operating system. This procedure is still the same with what we have, even with the hardware, with the operating system. The first thing here is you identify a problem, you establish a theory, you test the theory to determine the cost, and then you establish a plan of action to resolve the problem and implement the solution. So we could see here that the procedure for troubleshooting must go through actually these 6 steps. These are more or less the fastest way to actually carry out troubleshooting with the Mac operating system, so the mobile operating system. And then you identify the problem. What is the problem you are experiencing? What is the version of the mobile app, mobile operating system are you using? What service provider do you have? And then what apps have you installed recently? These are ways to identify some of the problem. And then has this problem happened before? I mean, still the same way of trying to gather information, questions, to be able to identify related problems. And when that is done, you establish a theory. And how do you do that? These are, the mobile device cannot send or receive email. So first, when you identify this problem by looking at the different questions arising, then here you now look at how to establish a theory. And that establish a theory of a probable cause. You're looking at, for instance, an app has stopped working. So because you have identified that, you're now saying that the app has stopped working. So what will actually lead to that? Then you test that theory. And then you establish a plan of action to actually resolve the problem that you tested. And then you verify solution, and then looking at verify full system functionality. And once you do all that, like we said, it's a procedure to go through, and you document your findings and actions, and then you solve the problem. So these are actually procedures. If you look at the troubleshooting process, they almost remain the same with the other troubleshooting steps we addressed in the previous classes. We did the same with hardware, we did the same with network, we did the same with our operating system, that's desktop operating system. So you could see here that the procedure for troubleshooting remain the same. So when you're reading through, you have to look at those problems, you identify them, you establish, you test, and then you plan out the action, and then you document your findings. Once you do all of that, automatically you resolve the problem. So our students should be prepared in such a way that that's 6 basic steps. They seem to understand it at every point in time in the normal complex IT environment, because they are bound to apply this in the different sectors of IT. And so that actually helps them resolve problems within an IT environment. So I think once we review those processes, it will help us to be able to solve some of the challenges that will come up with our mobile phones, with our computers, and all of that. So that actually brings us to the end of looking at our mobile as operating system of our mobile devices from the angle of the Android and the Mac OS. So any question, please, on this? But I want to believe that this will be quite easier for the students, because they all have their Android phones, they have their Mac phones. So even when you're teaching them this, they can actually relate with whatever you're saying, because some of them are already using it. They're enjoying the benefit of all that we have been mentioning so far. And so it becomes so handy for them, when you discuss a topic like this. So I want to believe we can actually handle this possibly, and so that we can help them through. to build up that required skill. Thank you very much. So, any questions so far?
Not from my side, guys. Do you have any questions?
I've really enjoyed the topic today. My only problem is I've never used the iOS and then the Mac OS as well as the Linux. But for the Android and Windows and the rest, I'm okay with them. I think I need to get some of these machines.
Yeah, like you said, it will be more interesting if you can lay your hands on one. It will go a long way to help you balance your knowledge in that area. For me, I think in the lab setup, that's part of all the things you should look at. So that the students will have the varieties and be able to play around them. Because most of them, if they have the Android, they might not have the iOS device, and so that actually limits their knowledge in that area. But if we have this in the lab, they can play around with it and actually enjoy it more.
The iOS is very nice.
Yes, it is.
But what? This Simon.
Okay, yeah, go ahead.
Yeah, but when you want to download an app or something important that is educative, mostly it is sold, and that's what is preventing most of us in Africa here purchasing iOS devices.
Okay, because of the cost implications.
Yeah.
In the long run, you need to pay for some of these apps. They don't come free. But in terms of security, it's more secure.
Yes.
And virus is very an issue with it. So you need to look at the benefits. But I quite agree with what you said when it comes to the Mac. In Africa, generally, most users actually, most people use the Android, unlike the iOS. But then there are lots of benefits using the iOS. But in teaching this, because our students are actually meant to practice this and develop that technical skills. So I think it should be, in my own opinion, it should be part of the lab bundle, or more or less the lab kit for practice, so that they can practice this. When they read through the material, they can come to the lab and go through it and play around with it. I mean, that will go a long way. Any other question? Any other contribution? Hello, are we there?
Yeah, I think it's okay if you don't have more questions.
Yeah, and I was talking about a teachback section for the instructors. Do you guys mind I give you topics as we go on, and then you come to, just like I said, 10 minutes or 15 minutes for each instructor will be fine. Are we okay with that? So do I give you a topic, or you select the topic yourself?
Okay.
Because the two topics we have left is security, and then we're looking at chapter 14, which is the IT professionals. So basically, the only topic that I think is technically engaging is the security. The last chapter has to do with the IT professionals. In other words, some of the behaviors, requirements, how to, communication skills, and all of that. So I think once we through with chapter 13, chapter 14 will just be more of interaction.
Mm. So we are talking, guys, about everyone choosing a topic and taking the place of the instructor for about 10 minutes and explaining a topic. Are you okay with that?
Yes, I am okay with it. I can speak for the others though.
So you would choose, or you want me to give you? So I can. Merely we can work on this, and you can assign each chapter to individual, and the person could just talk on that for 15 minutes, and then summarizes what he or she learned from that. That's it.
I think it's okay. Do you agree with that? If the topic is assigned instead of chosen?
Yeah. If you ask my opinion, I would say that early you can assign early chapter to them. Reason being that they are going to teach all the chapters. So for us to test their teach back capabilities is to just arbitrarily assign any of the chapters, and let's see how they work hard to be able to, teach back those chapters. Now advise and structure how best.
Okay, so I will assign the topics.
You assign it.
And this is for the last session, so next week?
Yes, actually we're supposed to round up this week, but then we're running up on Tuesday, so Thursday next week will be the final exam. Yes, Thursday next week will be the final, so maybe you need to tell the others that they'll be doing lab. There'll be lab exams, and there will be the theory exam next week.
So it's the 29th, right?
Yeah, Thursday night. So the final exam will be active. So I want to believe between now and Thursday next week, instructors will have completed all their chapter exams and are ready to write their final exam.
We'll do our best. We have some challenges, but we'll try our best.
Okay. Thank you so much.
Thank you. Bye.
Yeah.